This is the Chapter 3 review video. It's gonna go fast, but it's just a quick reminder of everything that you need. Solve with substitution. So solving a system with substitution is when we solve for one variable. So here, if I added 2y to each side, I have x equals 2y plus 3. I then plug that in for x. So 3 times 2y plus 3 plus y equals negative 5. That's 6y plus 9 plus y equals negative 5. That's 7y plus 9 equals negative 5. Subtract 9 from each side, and y equals negative 14. So y equals negative 2. Once I have that, I can plug it in up in this equation. X equals 2 times negative 2 plus 3. X equals negative 4 plus 3, or x equals negative 1. Write our answer as an ordered pair, negative 1, negative 2. That is substitution. Solve by elimination. We want to make sure that our equations line up so that the variables are underneath the same one. So I'll move this around so that my 5y is under my negative y. My x's are lined up and my numbers are lined up, so I can just add them straight because 5y and negative 5y are already the same. If they weren't, we would have to multiply. I'll add straight down. 14 equals negative 7x. Divide both sides, and I get x equals negative 2. Once I do that, I can plug it in and solve. 5y plus 3 equals negative 9 times negative 2. 5y plus 3 equals 18. 5y equals, subtract 3 from each side, 15, and y equals 3. Write that as an ordered pair, negative 2, comma 3. Solve the system by graphing. Our first equation is in standard form, which we use to graph our intercepts. If 2x equals 8, then x equals 4. That's my first intercept. 1, 2, 3, 4 on my x-axis. And if negative 4y equals 8, then y equals negative 2. And that will be my point on my y-axis. I then can connect the line through. Then I can graph my second equation. My second equation is in slope-intercept form, or y equals mx plus b. So my b is at 2. My slope is negative 3/4, so I'll go down 1, 2, 3, and over 1, 2, 3, 4. And then I can even go up 3, 1, 2, 3, and left 1, 2, 3, 4. And then I'll draw my line through. Now our answer will be the intersection of those points, which looks like that is at the x value of 1, 2, 3, 3, and the y value of negative 1. Again, these are estimates when we solve by graphing. Solve the system by graphing. First, we have an absolute value equation. Remember that absolute values are going to be shaped like a V from 0, 0. This tells us to go left 2 and down 1, down 3 with a slope of 1 over 1. So we will go to the left 2 and we will go down 1, 2, 3, and our slope is 1 over 1, so we will go up 1 and right 1, up 1 and left 1, and then it's less than or equal to, so we will connect them with a solid. And then it says less than, so we will shade below this line. Again, if you wanted to check your work, you could plug in 0, 0 and see if it made a true statement or a false statement. Our second equation is a line, so it should look like a line. And it says y is greater than 1/4 x plus 1, so our y-intercept is 1. And we will go up 1 and right 4 because of our slope. 1, 2, 3, 4. Or down 1 and left. 1, 2, 3. 1, 2, 3, 4. And then it's greater than, so we will connect it with a dotted line. And it is greater than, so we want to shade above that line. Now remember, the solution to this set is where the intersections of both of our shading meet. So that happens to be off to the side of these little corners over here and over here. And what that means is that either of those would be able to be plugged into both of those equations and make true statements. Now we'll get into some linear programming. Linear programming, remember, is just a way of finding our minimums and maximums. Let's start graphing. X is greater than 2. Remember that x equals graphs are going to be vertical lines, so this will be a vertical line through x equals 2. And it says that x is greater than 2, so we'll shade on the numbers that are greater than 2. Next, we have y is greater than or equal to 0. Remember, y equals graphs are always horizontal lines, so this will be a horizontal line through the y equals 0. And again, it says greater than, so we will shade above that line. Next, we have an equation that is written in standard form. This is going to make a line, and we graph standard form using intercepts. If you would like to change it to y equals mx plus b, you may. But again, I like using intercepts. So, if 3x equals 12, that means my x-intercept will be at 4. So at 1, 2, 3, 4, I'll have a point. And if 2y equals 12, then at y equals 6, I'll have another point. 1, 2, 3, 4, 5, 6. And then we connect with a line. It says that y is less than that, so we need to shade below the line. And remember, the goal of looking for a minimum and maximum is to find the vertices of the shape that is created by all of the constraints. So if we are looking for the vertices, we see that we have one here at this point, one here at this point, and one here at this point. Let's go ahead and name those. It looks like the point 2, 1, 2, 3, and 2, 0, and 2, 3, 4, 0. Now I just realized I forgot to write down the objective function. The objective function here is c equals x plus 5y. So we need to see what minimizes and maximizes that by plugging in. So I'll start with 2, 3. 2 plus 5 times 3, that's 2 plus 15, that equals 17. Now 2 plus 5 times 0, that's 2 plus 0, which is 2. And 4 plus 5 times 0 is going to be 4. So 2, 3 gives us our max, and 2, 0 gives us our min. I don't have time to go through solving systems with 3 variables, but you will need to be able to do that using elimination and substitution. Solving using matrices, remember we need to put it first in a matrix. This is a 2 by 3 matrix. And then we need to try to get everything to cancel out. So first I'm going to multiply my top row by a -7 and then add them. So -7, that'll give me -49 minus 14 minus 35. And I'll add my 13, 14, and -1 to that. When I do that, I will get a -36, 0, and -36. I'm then going to replace my top row with this new row. I can then divide my top row by -36, and that will give me 1, 0, and 1. And my bottom row is still 13, 14, and -1. Remember, we needed the diagonals to be 1s, so let's get our 13 to cancel out by multiplying my top row by a -13. When I do that, I'll get -13, 0, -13, and I'll add that to 13, 14, and -1. When I do that, I will get 0, 14, and -14. I see right now I can divide that by 14 and get 0, 1, and -1. Plugging that into my new matrix, I get 1, 0, 1, 0, 1, -1. This means that my x equals 1 and my y equals -1. And that is how you solve a system using a matrix. If you need extra review on any of those topics, go and watch the previous videos. That's what they're there for. So our joke of the day: why does Snoop Dogg use an umbrella? Bo drizzle.